Hi everybody, this is Richard Koch, or Koch in German, from Koch SMD. Thank you very much for joining today, appreciate it a lot. If there's any problems with the sound or anything, just please message in the chat. I'm monitoring on YouTube and on LinkedIn. With that said, let's start. So we're here to talk about 62304. So obviously for medical device software, this is an important standard. It's one that comes up a lot, and one that personally, in my view, I've never actually seen particularly well implemented. There are better and worse versions of it. And I think there are some common issues around it, one of which is training. And the idea for this webinar sort of came from two areas. One is a response to sorry, I had something in the background there. It's finished now. One is a response to job ads, which require highly technical roles have a very good understanding of 62304, which I guess is an advantage, but probably should not stop recruiting depending on the role. And then also, lost my chain of thought. I very apologize, guys. Okay, I'm just going to move on. Got distracted there. So once we move on, so why are we here? Basically, we're trying to identify what are the correct IEC62304 responsibilities to support safe, performing, compliant medical device software. And the key part of that is the engineers and how you should train them. So just a quick transparency statement. This is obviously my views only. Your business could be very different. This is not advice, and it's only for educational purposes. That said, this is what I do in my own business. So quickly, this is me. I've got a background for the last basically 12 years in medical device, in quality management, finance, funding startups, managing a medical device supply chain, and SMD product development experience. That's screenshots for my own product. We're pre-registration, but I do have an ISO 13485 certified company with SAMD scope. And we're just starting the pre-registration scale up now. The last release, we released the latest version last week, and we're heading towards our first global registrations, hopefully next year. We'll see. So what is the training problem with engineers? This is a meme that was on LinkedIn the other day. I don't know this company, but a good meme deserves a bit of promotion. And we have here SAMD regulations running over a happy agile developer. And hopefully this is staged and not a real picture, first of all. But regardless, I think this is something I've observed in startups and also in legacy device companies trying to do medical device software or cloud software for the first time. You recruit developers which have good agile background, or you buy, in a lot of cases, your contractor who did your software before, who are very agile, but when they get into the regulations related to medical device software, it all kind of falls apart. And we find high team stress, we find a high non-conformities, a lot of pressure, and unfortunately a lot of this stuff comes out prior to release because people dive into detail, realize probably can't release, pressures on the team, and you see really good people really suffer, and unfortunately a lot of cases devices not launching on time. Now from my point of view, this is my version of the meme. I think it's slightly different. While there is an effect on the developers, non-compliant SAMD development, basically the medical device regulations prevent market access, prevent the opportunity to earn revenue, present issues to your market share, and ultimately prevent patients getting the care that your product can give them. So it is a bit like a car crash, and I think this is the best case for non-compliant medical software, but we also see a lot of cases where products get recalled. So these are some statistics from a new product I found. You can see it on the right-hand side, recalls.fyi, which is what you're seeing the slides from, recall database, and then we have the complaint database more 2.0 and the link below, which I believe is in development. I'm planning to use this for my post-market surveillance data. And you can email Jesse on that email address if you're interested, or go to his website. He provided me these screenshots. So yeah, we see a lot of recalls, especially around software. And they just continue to happen for various reasons. And I'm sort of almost of the view that the majority of medical device software, cloud software, is probably not compliant. It might be performing, maybe it's secure, who knows? But if you're a software developer, this is a huge risk for your business around compliance risk, patient safety, and clearly revenue and reputation. So I think in both cases, to avoid these, we need compliant software released. So from those last couple of slides around importance, I think it's clear that 62304 and the other regulations are important to your device, clearly. And if you're a startup, if you're an owner, investor, or leadership, this can be the difference between you staying in business, going bankrupt, or your CFO having a heart attack because maybe he's got to take a really bad deal at the next funding round because you haven't delivered on your product roadmap and your business is worth less because you need money to get you where the last round was meant to be. And if you're a public company, shareholders, depending on the product, public companies generally have a larger product range. They're not single product companies like startups, but more and more, especially the replatforming of on-premise products to cloud, can have a major impact on the shareholders, the board looking at company performance, on leadership achieving their goal, and clearly your customers' expectations about either having a product on time as delivered, or when they do get the product performs, is safe, and they're not suffering product issues, patient problems, or unfortunately recalls. So clearly it's important to these groups. Now we talk to the engineers. This is a slide or a demonstration of a pit crew. And engineers are the guys who make stuff work. And, in some ways, they sit in front of keyboards and make miracles happening. I'm a little bit older now. I wouldn't have thought that half the stuff we're doing now was possible when I was born all those decades ago. And here we've got like a very interesting example of an analogy we can apply to our software teams. We have, maybe there's 20 people on the slide, all performing different tasks. And what they're doing is the car comes in and 1.923 seconds later, this car leaves the pit stop, goes on the track, the tires are changed, the fuel is refueled, other things are done in this very short period of time. And all of those people, while they're executing those tasks, they're thinking of nothing else except for the wheel nut in front of them, the tire they've got to put on the rim, the jack to lift or lower the car, just very task focused, but coordinated and as a team. And the ones who are making that coordination happen are really sort of two things. You've got the guy in the car who wants to be back on the track. And I think the analogy there is that the driver in this scenario is like our commercial managers, the product managers. They're not really R&D. They have to coordinate with R&D, but they're highly dependent on R&D to get on the path. And the pit lane spotter, who in the best case stands there and does nothing because everything goes so smooth in that 1.923 seconds. But otherwise, he's there to coordinate, make sure things are going, get involved, guide the team if there are problems, and give the commands for stop, go. He is similar to the R&D manager. He's got a job to do. He's got a team around the product. He's got to coordinate those activities. So if we just hold that analogy, this is very similar to what we see in the product teams. And the engineers, at least in my view, they're there to do complicated things really well, deliver and perform. So we expand the car analogy a bit further. In any complex industrial process, there's probably very few people, if any, who know the whole process end to end in all its details. There'll be some people who know more than others, but a prerequisite for doing complicated thing is not that one person or everybody on the team has to know everything. There needs to be a leadership team which is responsible for certain parts and to make sure it's integrated. And at the end of the day, the car comes off the line, it's compliant, assembled well, or our medical device software is released it's compliant, well documented, it's safe, it's secure, and we need to make that occur. So in my mind, if you're the guy on the line screwing bolts together, or you're the engineer configuring an environment, coding, whatever, you need to do that job very, very well. But do you have to know detailed the whole process? I would argue no, generally. But as you go up the chain through the hierarchies and responsible for more and more, yes, it does become more important. But just this blind approach where you see these very highly skilled engineering job posts on the internet requiring 62304, at least in my view, I may question that. And I don't know these companies if it's a nice to have or a must have. It's obviously good if they have it, but I don't think it's necessarily a prerequisite to hold a job or to get a job. And I'll explain why in a second. So we look at IEC623, the characteristics of that standard. First of all, it's a process standard. It's the standard that focuses on process. And that process is from your software system requirements to verification. So depending on the complexity of your product, it could have different levels above. But 82304 generally covers software, so the product requirements, shall we say. And however, the process is also interdependent on other processes. So it has to comply to 13485, 14971, 62366, 62306. And again, depending on the complexity of your product, your country regulations, there are a lot more. So it is not a standalone process. It's also a large standard, 65 pages, excluding the annex. At the end, it's got 95 clauses, and those clauses start from post the definitions and end just before the annex starts. It's multidisciplinary, so it requires many skill sets to implement it effectively. And it requires an operational thinking to implement, which is something I'll touch on a little bit later in this, where you really require something similar to a supply chain sales and operation planning thinking to manufacture compliance. And I'll try to explain what that means. So Agile alone is not enough. It's part of the way there, but it really requires a lot more planning and operational thinking that at least I've seen. And from what I've seen from my limited customer base is that a lot of the required operations are under-resourced in teams. And this is something the industry may have to think about. What the standard is not, it's not a standard that defines methods. So there's a lot of missing detail on how to execute it behind each clause. It doesn't define tooling. Theoretically, there's one very talented DevOps manager who told me that you can write your code in text file or Word. It doesn't matter. It's up to you. You could do it. Doesn't 62304. You could comply to 62304 and write your code in Word if you wanted to. I don't think anybody would want it to, but hopefully you get the example. It's not a standard that's DevOps focused, so it's not DevOps focused at all. Although we do see in the industry that a lot of people think it's something that's very DevOps focused. There are parts which you need DevOps approach to execute clearly, or at least execute efficiently. But it's a very broad process, and DevOps is more from the code to release, going up the design V, where 62304 really covers a lot, if not all, of coming down the design V. And again, we'll see that in a second. I think that's an area that's largely missed. So we look at some of the tasks that occur in 62304. We've got across the top the categories. There's planning tasks, design tasks, coding tasks, DevOps tasks, documentation tasks. And in each of those categories, I've highlighted in orange, what are probably things that Agile teams or engineering teams are probably used to, like managing a backlog, doing architecture, coding, testing, building, deploying environments, etc. But there's also, a lot in there which is not. And especially if you go to the right-hand side, the documentation side, working especially on my development team, which came from non-medical projects, they're actually surprised at the amount of documentation we do on my own software product. They've never seen it before. They've never seen the control we implement. And, I've seen that also in a lot of other businesses where you get very complex products, and a lot of the documentation is really missing. It's really bare bones. And there is a big difference there between just doing tasks to fulfill compliance and actually doing it properly, so you actually can deliver. But the point here on this slide, there is a mix of what I would call engineering and non-engineering tasks in 62304. So if we look at the design V, and this is a slide I've developed myself, where we have the V in the middle, which is everybody will have seen before and hopefully makes sense. I've adapted a little bit to the 62304 language, where we come from the top, from requirements into specifications, into detailed design. And then at each of those steps, we have to risk manage each of those steps at each of those levels and make sure that our requirements, specs, and design mitigate the risks we've identified. We then go to implementation, we implement it, and then we come up on sort of two vertical axes where we do system tests in a dev environment. So on the far right-hand side, there are our environments. And then as you move through system testing, verification, validation, finally to release, we move our code, our product through those different environments. And again, this is a view. There are different ways of doing it, of course. Little bit, anyhow, we won't dive into that. And at least in my experience, and again, hopefully your project is better than this, the ones in black are generally not great. We'll come to that in a second. The ones in orange could be okay or not okay. It kind of depends. It gets a bit closer to coding. And when it comes to writing code, merging it, releasing it, generally the teams I work with are competent, good to excellent, like amazing, like just so impressed with what they've built. But unfortunately, something that may be good for non-compliant software, e-commerce, any sort of other non-regulated functionality, no matter how well engineered it is, if you don't have the documentation, you can't release. It's not compliant. And it's a little bit like going in front of the court to the judge. It's not what you think is true, it's what you can prove is true. So if you've got the best engineered, highest performance, highest safety product, without the documentation, all the stuff coming down the V, you cannot register it. So again, there is a large overhead for medical device software, as I know this audience knows. But again, in my experience, I've seen, really a lot of missing documentation. Things like 5 to 10 risks for a very complex high-risk class system, 20 requirements, 10, 20 specifications, these sort of things. And, they're done with good intentions, don't get me wrong, but there's no way that any software project, at least in my view, should have at least a few hundred requirements, few hundred specs, if not more than that, getting into the single-digit thousands or more, especially if you've got a global rollout, if you start looking at global regulations. So, moving on. Now, the good news about software is that unlike physical products, you actually have a very key design control, which is at the pull request. And what I'm proposing more and more to my customers is that I try not to engage in waterfall discussions, agile discussions, these sort of things, because what one customer calls waterfall, another customer calls waterfall is completely different. So there's no common definition across my customers I've seen. Everybody seems to have a different view, and it's the same for agile. So I don't really look at the names. I look at the procedure, what they do, compare it to the standards and say, look, is it compliance or not? Now, from a code perspective, before I do that, I'll try and explain this procedure. So it's basically the design V up until deployment without the testing and verification. We've got Jira. This is how I configure my Jira board. We've got a product requirement ticket, causes a software requirement ticket, which causes a detailed design ticket. And I've got various ticket types on there. And then that goes in sort of basically two directions. You either code a ticket and then merge it, and that's part of your product. Or if you come to the bottom, you have a configuration ticket, which is not a coding task, but it could be configuring AWS, configuring a build agent, configuring distribution, Google Play, these sort of things. And generally for both those tickets, I also have a documentation repo. So if there's code happening, I'm updating the detailed design documentation and the documentation repo. So we've got one ticket, two branches off that ticket, and I did a presentation on that earlier this year. Or it's a configuration task. It's a configuration task that's documented in the product documentation. So we've got this sort of link from one ticket into 2 different repos, into 2 different branches. Now, a lot of people, again, with the agile approach, the code will generally be tested before it's merged, sometimes better and worse, but the testing is understood in software development. But I would say generally, as a rule, and this is a discipline thing, the software teams need to develop a medical device definition of done. So what that means is I'm not going to merge the code unless that branch is, for example, and this is a checklist, my branch is linked to a detailed design ticket. The documentation has been done, ready to merge, shall we say. That detailed design ticket is caused by a software requirement ticket. That software requirement ticket is caused by a product requirement ticket. That the risk management has been done, that all the risks have been considered, that the implementation of the design, the requirements, etc., mitigate the risks. And then each of these tickets are covered by tests, etc., etc. And I think this is actually really critical, and it's a discipline thing, because you could merge the code and leave the documentation to later, or leave the risk management to later, what have you. But ultimately what you're doing is creating a backlog of work that has to be done, and you're going to pay for it eventually. But if you build the discipline and say, no, we're not going to do it, maybe your project in the short term slows up as you need to regroup and start doing documentation before you merge the code, but eventually you'll get on top of it. And what we're looking for here is the real incrementalism. Once that code is merged, your documentation is updated, and everything, back up the V is done. And it's pretty easy once you get there. It's a big job to get there, is either if you have a project which is poorly documented, or you're doing your first increment, your first release. But there are ways of managing it as well. But once you get there, then I think you can really live the promise of incremental agile, which is, fast, accurate deployment of your product. So what to do? So I'm saying don't train everyone in 62304. So what should we do? I would say plan for outcome here. This is really important. You need to decide what you want to get out of your software project, your software team, etc. And that should be compliant, safe, performing product, but also done highly efficiently with the minimum bugs, lowest cost, what other metrics you put in there. And before you get to training, there's a lot of things you've got to go through to get there. First is, in your QMS, make sure you've got compliant SOPs, compliant QMS procedures, especially design development procedures, risk procedures. In your design and development file, your compliant design and development plan. And again, this is hugely critical, because I see a lot of customers, they do plans just to tick the box. So they get audited, they have a plan. But this really has to be a live document and really thought through, and that has to define the play on how you're going to implement your product. Fit for purpose toolchain. Again, this is one I'm personally critical of. I will show that in a second. Well-designed sub-processes, which are then documented in accurate and actionable work instructions. Real quality management system profiles. Again, just not box ticking, but actually working with hopefully an HR professional who can help you with organizational design and doing that. Not just somebody who's filling in a QMS template for a profile. This has to be really around organizational performance. And then from those profiles, get to your training plan. And that training plan will determine what you train. Some of those people may need full IEC62304 compliance, especially if you're on the project management, project leadership side, absolutely. And there are engineers, senior engineers, who need to know the full process. But that has to come from your QMS role profiles, which is based on all these precedent procedures you've got. And then for that, you just basically train on the training plan, and you are training for the outcome you need. So coming back to the Formula One example, if your engineer is there to screw off and screw on wheel nuts, and they just have to do it really well, work with them to make sure they do the best job they can, because they will work in a team and they will, everybody does that, the whole project will go smoothly. So talking about tool chain, there is a problem in our industry as I see it, especially amongst manufacturers who come from physical manufacturing with traditional sales operational processes, is that the tool chain for their software products, especially around documentation, are not fit for purpose. And the analogy I come up with is that doing software is a little bit like doing a Formula One season. And with software, you design once, you release once. There's a one-to-one match there. So you release once, it may be replicated God knows how many times, but that design, that manufacturing process of taking it out to your production environment, releasing to customers, is done once. And it's very similar to a season. You take a Formula car, you fly it from the factory to the track, and then you configure it, it runs a race, and then you take it to the next track, which is a bit like our next release, and you keep doing that, and then the car changes over the season, it's a better car, and maybe next season it's a major release, it could be a completely new car, but it's an upgrade, right? So you go through these very fast iterations. In Formula One, I believe, they finish the race in the evening, the car could be on the plane to the next destination that night. It's really that fast, and there really is a lot of planning and coordination there. So software, especially cloud software, not so much on-premise embedded in the device software, that's a lot slower. You have these rapid iterations where you design once, release once, you move on to the next. However, on the right-hand side is a bit more traditional manufacturing. You design once, you have one master device file, and then you release many, many times. So, you'd be lucky in some, depending on the product class, some master device files don't get updated for years. But that factory is just pumping out hundreds of thousands of devices over, for one version of your device file. And, it can put up with a tractor, right? Tractors are great. They can, run around a field, plant once, do it, whatever. It's very slow moving. But unfortunately, what I see is when software development teams are forced to fill in non-fit for purpose EQMS systems like Greenlight Guru, there's others out there, I'm not going to mention names, they want everything to basically be done through Microsoft Office, Word documents, manually convert to PDFs, manually upload to SAP, Pronovia, or other document management systems. It just kills the team. And I'm very much of the view you need to deploy the documentation like your code, Git-based, just clone, replicate, sub-branches, merge, get really good control on deployment. Your engineers, your team know how to do it. If your quality department don't, train them in how to do it, as opposed to, the reverse, training your team in the EQMS. And this is one of the biggest problems I see in compliance, performance, inefficiencies in teams. And I think the next webinar I'll do will be on this theme, why your tool chain for your medical device technical file has to be different, but can deploy to your company's QMS. And finally, we get to planning. If you look at manufacturing, they really invest a lot in manufacturing. I've been a medical device supply chain manager. Before that, I've spent a lot of time either in doing sales operation planning or getting involved in these sort of things from either in supply chain or finance point of view. And these companies spend a lot of money training, looking at their models, systems, processes for planning before they get to manufacturing. So one of the previous companies I worked for was Kimberly-Clark, making nappies. And these nappy machines are about 20, 30 meters long. They've got thousands and thousands of moving parts. And they can produce nappy in about, I think, 100 nappies per minute. They're about less than, more than a nappy a second. And each of these nappies have about 100 different components. And it's just fast throughput, continuous. And I can't fully remember the numbers, but they may do a production run for a week or two. And then that machine will be shut down for maybe a month while it goes through service maintenance before the next run. So the ratio of planning, maintenance, configuration, ordering products, you name it, is immense, and the actual having people on the floor operating that machine is actually the lowest consumption of resource and time. And again, what I see with the agile approach, it's a bit like putting people on the floor. You put your developers to code on the floor of your theoretical factory and deploy, and without all the planning. And like I said, again, what I'm seeing in a lot of software, medical device software projects is there is over-resource on the engineering DevOps side, and there is massive under-resource on backlog management, quality management teams, testing teams, this sort of thing. Now, hopefully the people on this call have it under control. I obviously don't see everything, but this is an issue not necessarily for the R&D managers. I think they see it because they suffer it, but generally it can be a misunderstanding from the senior leadership. And again, especially from companies which are led by people of maybe my generation or older, I'm 50 now, who grew up in an old paradigm, maybe not so digitally based, and they just don't understand. And I think we'll see that change as we see more and more problems with software and realize that to do good software, it's very expensive, there's a lot of overhead, and they need to invest probably the balance of resource. I don't know the number yet, but for every hour of coding, there's probably 5 to 10 hours of non-coding tasks in medical device software, obviously depending on the complexity of that coding task. So plan would be that. And then obviously in the theme of the webinar, train your team for what they need to know to execute on that. So we'll wrap up now. That's been 30 minutes. So before we wrap up, just say if you've got any questions, pop them in the chat. There is a little bit of delay on the stream. So if you ask a question now, it might be with me by the time we wrap up. If not, you can message me or comment on this after, and I'll try and address. So the summary, in terms of who 62304 is important to, this is a leadership issue, and obviously there's a level there, but if you're the R&D head, you need to know 62304 intimately, and you need to make sure that all of your design process, your tool chain, your training ensures that when your organization performs, everybody does their individual tasks. The product you produce has been produced according to compliant procedures. So the R&D leaders have to be experts or rely on experts in their teams. 62304 requires a lot of detailed planning to achieve compliance, and the critical success factors for that are obviously your QMS, design and development plan needs to be really well thought through, role-specific training. Your tool chain has to be fit for purpose, and I would say it's not an EQMS, it's not Word, it's not even Confluence, although there are better and worse examples of that. Engineers has to be trained on actionable and accurate work instructions, and really just focus on the outcomes of your team, adapt, improve, and things go well. So that's it. I don't think there's any questions I can see. So if you, I'll just wait a couple of seconds and see if there are any questions. And if not, then we will wrap up the presentation. Like I said, I'm a consultant. Obviously, you're free to hire me. If not, I'm very happy to speak to anyone. So feel free to give me a call and have a chat just about ideas. Sometimes people find benefit in that. Otherwise, if there's no questions, I want to thank you for the time. There's a lot of things you could have been doing today. You've chosen to be here. Hopefully this was of value. There was really a lot of content here in 30 minutes. It's the first time I've done this presentation. So please do give me feedback on what went well and what didn't go well. That helps me a lot. And I wish you a good weekend coming up, and thank you very much for your time. Cheers.